Okay, so we're ready to start. Hello, everyone. Thank you for joining us today at our first Fwdays Python online meetup. Today we have two speakers, Henrik and Guray. Let's start from a little introduction to what is Fwdays actually, because you're now with Fwdays meetup. So we've been organizing events for 10 years already, but this year we're going online, and our second Python Fwdays conference going online as well this Saturday and next Saturday. And this is kind of a pre-meetup before the conference with two great speakers as well. So the Python Fwdays conference will be held online, and we'll have 10 talks. 3 of them are in English, 7 of them are in Russian. You can check the agenda with the link under this video if you're in the YouTube stream. As well, you can just go on fwdays.com and check the agenda there. All the talks are there, all the speakers are ready, they're just waiting for you. So you can join us as well on Saturday if you're already registered. If not, you can still have chance to buy the ticket. So let's start with the first speaker, Guray. Hi.
Hello.
Yeah, hi. So you can just, we have some attendees here already, and as well, we have like 50 plus people watching the YouTube stream. And you can share the screen now. So we'll see their presentation.
Okay, I think it's ready for.
Yep. Just a quick reminder. So if you want to ask a question and you're watching YouTube live and you're not in Zoom, because in your email digest, there were 2 links, one for YouTube and one in Zoom, and you can just swap it. You can just go to YouTube or go to Zoom as well. So if you're watching YouTube broadcasting, you can ask the question in Telegram. Just go onto this video. In the description, there is a Telegram link. You can go there, join the Telegram, and during the talk, you can ask your question. Just make a hashtag QA, and then we will take your question and say it out loud after the session. Or you can just join Zoom anytime, and after the session, you will have the chance to ask your question just out loud and have your answer straight away. So yeah, Guray, you can start.
Okay, thank you for the introduction. So hello everyone. I want to talk about managing Docker containers with Python, and we will talk about how you can do the management stuff with Python, and you can manage Docker using Python codes or interactively with Python shell. And actually, we will also talk about why we should do the stuff or why we should bother with implementing these things. But before starting, I want to introduce myself because I think most of you didn't see my name before. So I think an introduction would be great for that purpose. So I am an independent consultant, and I am giving some consultancy services about DevOps, DevSecOps, and NetDevOps stuff. And before DevOps side, I was working on embedded systems, and I'm an electronic engineer. So I switched my job and started my career from zero in IT field and in specific DevOps and Python related stuff. And I've been coding some stuff in Python for more than 10 years. So when I switch to Docker, I see that there is a library which integrates Python with Docker, and there are a lot of possibilities that we can achieve using that library. So I want to talk about this, but in case of there are some people who are not familiar enough with Docker, I will introduce Docker shortly, and afterwards we will talk about the applications with Docker and Python. So Docker actually is one of the mainly used container technology implementations. Docker uses Linux kernels, some technologies of Linux kernel, and provides us containers that are easily managed, or we can just create containers, manage them, and do the stuff using Docker easily. And what it provides is actually, in short, it helps us packaging, shipping, and running our applications easily, really easily. And it's a lightweight applications, just installing and setting up it in our computers and starting developing using Docker provides us packaging our applications easily and sharing it with our friends, our teammates, and actually shipping to the production will become much easier and much effortless when we are using Docker. Actually, it solves one major problem, which is it's working on my dev environment, but it's not working on production environment because it's packaging our application with all of its dependencies, including static, dynamically linked libraries and other stuff which is necessary by our operating system. It only uses the operating system's kernel in common, and all other stuff is packaged along with our application. Think it like, we can just think it like a box which includes all the necessary stuff along with our application. So our application can run in any environment if the environment is running on Linux. So it's basically what Docker provides us by default. So in specific, the second question is what Docker provides a Python developer? Because we are coding in Python and we try to write some codes to make our lives easier and make our customers' life easier actually. So the question is what it can provide us from day zero. We can use Docker Python module that integrates Docker with Python to implement some command line interface tools that are not available or that are not working in a way that we can use. And the second stuff is we can design special purpose pipelines. We can write our custom CI/CD engine, and I will introduce one open source CI/CD engine today, and I will share the source code with you as well. At the end of the presentation, I released it on GitHub in 1 or 2 hours ago, and afterwards I will show you how we can monitor Docker and Docker itself and its containers, as well as how we can apply some compliance things like just run applications from that whitelisted sources, and if the source of the image, of the container image, is not in the list, just deny and remove that container. So I will show you some code examples in a couple of minutes that will help us to implement or achieve the compliance things or some increased security in container image name matter. And afterwards, what Docker Python module provides us is actually we can manage our clusters. For example, if you are implementing Docker Swarm in your production development or staging environment, you can manage your stuff with Docker and Python, and you can just write some codes to watch your program and act according to your program state, like increase the number of replicas that are currently running on Docker Swarm or decrease the number. So basically, you can achieve auto scaling according to your custom business logic and your needs. And a lot of different possibilities are enabled when you are using Python and connecting Docker with Python. So the first question is actually how Docker Python module connects to Docker under the hood, because we should know how they are connected to each other, and afterwards we can manage the connection. So actually Docker itself has a REST API. Using that API, we can create containers, we can create images, we can delete them, or we can start, stop, pause, remove, kill, or we can make all of the things we want, and Docker allows us to do using that API as well. Actually, when you are writing some commands in command line like docker run, docker stop, docker service create, or some other stuff, Docker command line interface is also using this REST API to make some job to Docker. So Docker is listening some API endpoint, and what we should do is just reaching that API endpoint and sending some requests and checking the responses, whether they are completed successfully or not, or what is there. So Docker itself by default is actually listening a Unix socket, which is not a IP socket, which it doesn't have any IP address and port number, but there is a file, a socket file in Unix systems called var run docker.sock in your Docker, in your environment, which Docker is running on. And we can just connect to that endpoint and ask some questions. And there is an example at the last line. You can just use CURL and connect to that endpoint instead of connecting an API. So here, CURL has a parameter called Unix socket, and you just provide the endpoint to CURL, and it will connect, it will make a request and get a response back to you. Actually, it has a really simple meaning. You can just use requests library, which you are probably familiar with, and connect to that endpoint and write some codes according to it. It's possible from that moment and so on. And afterwards, if you want to create a library, you can implement some functions, classes, and some other things, modules, libraries, etc. And you can reach your final state using request library by default. And also, we have Docker Py library, which has these features by default, which has rapid Docker API and provides us a really simple to use endpoints, objects, classes, and some other stuff that are really Pythonic and easy to use. So what we should do is just installing it using pip install, and the library name in PyPI is Docker. Pip install Docker is enough for installing it, and afterwards just we will import Docker as a module, and we can just create a client that will connect to that connect to the Unix socket endpoint and make requests. So the last line is actually written for that purpose, and afterwards it is ready to connect and create containers, list them, remove them, or make some stuff on the running containers or Docker engine itself. So it's just like that purpose. And afterwards, actually, we are really in a good state because we can just ask Docker about that client, and I will show you an example right now because I want to make it with applications and demos as much as possible. So I will create a Python 3 virtual environment, and it will be completed in a couple of seconds. Okay, and I am activating that environment, and afterwards just installing Docker Py library. It's cached in my computer, so it's kind of speedy. And afterwards just importing Docker and providing or creating a client object from Docker that, let's see what was the name. It's just, sorry about that. Yes, from environment. And now I can just see what it provides to me. And here are the API itself. It's a low-level resource to connect to API. but more importantly, there are containers, there are images, events, and a lot of other stuff. So it's really intuitive to use that library. And by default, as you guess, containers provides us some information about the running containers. So what I am doing here is just requesting container list that are running now. So it actually returned me two different objects, and these objects actually hold some data, keep some data about the running containers, their image states, and we can also access their logs from here as well. So let's get the first one and question what we can do over it. And there are some of the methods that we can just use, like we can just stop that container, or we can just kill the container immediately, or we can remove, rename, pause, start again. We can see its ports, its name, ID, and a lot of other stuff. But I will show you some more useful examples. So I am pasting it from here, and I will get the details in a couple of minutes. We can access some attributes of that container by just running, let's see, yes, it was A. Its attributes is here. Let me show you the command I have written again. And if I actually import pprint and pprint.pprint, its attributes will help me to show you in a good manner. Actually, this output is just like Docker inspect command. If you are familiar with, I will show you that command as well. And it is actually providing me a lot of details about the running container. So I can filter them, or I can just record them according to my needs, or I can post them to a monitoring system and record the state, creating alarms according to state, sending them to Telegram or some other application that I want to integrate it. And afterwards, I will be ready to actually utilize as much as possible these library. So it's what it provides by default. And if you are just asking Python for its keys, there are a lot of different groups here. Actually, we have seen some of them. And for example, if we just want to access some information about when it's created, it will return me a timestamp about it, and actually date about it, and I will parse them, or I will pass it through a actually decoder, and afterwards give the timestamp back. So there is an example I will just show you, and I don't write it because there are some more useful examples. But if you want to just parse the time zone, sorry, time that it returned, just writing this command, and afterwards we can actually question how it is old, and we can create some alarms, or we can just list the containers older than 30 days with just this code, because there is a for loop which questions, which iterates through every container in the list, and it is just getting the creation time of that container, specific container, and actually taking diff from the current time to the time container is created. And if the time difference is greater than 30 days, it will create it will actually print a message that have the container name and how old it is actually. So actually the major stuff is actually starting from here. What else can be created? What useful stuff we can create using this module? Actually, the first one is just watching the changes in the Docker engine itself in the real time. It's just like the Docker events command. if you are familiar with. Let me show you in Tmax environment. So if you write Docker events in one side, and if you write a command like echo hello and press enter, you can just watch how the container is created, how the network interfaces are created and connected to container, and you can also see when it's destroyed, it's stopped, and all of the state changes in the real time. So it's basically what Docker events is doing, and we can actually access all the details in as a Python dictionary using Docker Python method as well. So the first example will consist of it actually. I will just change my directory to here. And now I will just run the first demo, and afterwards we will talk about the source code as well. So if we just write that script, it will show us all the state changes in real time. So I am creating a new tab and writing docker run, sorry, the same command again, Fwdays, and the container is created. It actually echoed the message and afterwards exited. So our script here is just printed all the state changes. For example, here we can understand that it created a container, and the container image is Alpine because I have written it here, and my some details I provided are echoed to me. And afterwards, I can just question Docker API about the container which has this ID. With this ID, I can get a lot of different details or parameters that I provided to Docker command as well. So we can actually watch the Docker API in real time. And now I will show how we can actually watch this API. What we are doing is just getting the client and connecting to Unix socket that Docker listens our API request. And afterwards, we are just starting a for loop, which is a blocking loop. The client.events object, or sorry, method here is a blocking object, and we can iterate through it using a for loop or some other methods you are familiar with. And afterwards, it will produce some object, actually one object per event. And when we are listening that events, we can just print what's happening, and we can just get the details, which container is created, when it is actually fired, and some other stuff. And using that, we can implement our real-time monitoring stuff or some tools that are actually watching it in real time. So in the second example, actually, what we are implementing is we are watching that change, that events that Docker is firing, and we are filtering the containers if they are not produced by an image that we are whitelisted. So some user is just running a container in our environment. And in order to create a container, a user should provide an image with a tag. And the image may be downloaded externally from Docker Hub, from our local registry, or from some other places like Guray.io or some other Docker registry. So what we want to make is we are trying to restrict our users to use only whitelisted images. We don't want our users to use, for example, Postgres, because our environment may not use Postgres in any manner. So we only want to use whitelisted images from trusted sources or from sources that we allow. So the second example will include it, and here is the source code we are providing. Sorry. Yes. Here, what we are trying is actually, we are checking the image. But before that, we are just defining one Python tuple that will include whitelisted or allowed image registry. So here, the local registry, which is installed on my computer from local registry image, and the Alpine image from Docker Hub are whitelisted. But all of the images other than this are not allowed to run. When you run a container using any other image than this list, the container will be killed and removed immediately. And all of this functionality is provided by Python script that I will show you now. And here are the allowed list, and here are our main function. And it is actually just watching the events real time, just we saw in a couple of minutes ago for event in client.events structure. And we are just deciding in one line whether it's allowed or not. And the check event function decides whether the event is allowed or not. And here is the main structure that we are trying to follow, because we are providing the user a chance that whether a warning will be created and the container is not removed, or just show me the warning, okay, it's required, but also remove the container immediately after it's created. So when user press enter after running docker run blah blah blah, the container will be removed immediately, so there is no chance to run the container for more than 1 second or so. And here are the main stuff, because we are checking that if the event type is image, actually we saw some examples here. There are a type field in events JSON or dictionary here. It may be container, it may be image, it may be some other stuff. So we are trying to see that whether it's image that is pulled or whether it's a container that's created. And we are just getting the image and checking whether the image is in the allowed image list or repository list or not. And we are here checking the list which we defined here. And if it's in that list, we are returning true. If it's not that in list, we are just returning false. And according to this structure, we are just deciding whether it's removed or allowed. And according to that result, the container will be removed. Let's run it by just writing Python for Py, and it has started now. And if I run Alpine here, it will just show a message like contains created, and the image used is named Alpine, and it will not touch our running container. But let's try running Nginx here by providing port mappings like this. And after I press enter, it says that container is marked for removal. So that there is a request. There's a request that made to API and requested the container to be removed. So I can't even start it, and the container is removed immediately after it's created. And our script has just showed the message. Yes, a container is created using the Nginx image, but it is not in the allowed list. So a request about the forced removal of the container is made. That was the container ID, but it's killed and removed. So we can't even run our container from its creation time. So it's what we can easily implement in a couple of lines of code using Docker Python module, and it will provide us the chance of actually implementing some security stuff, whitelisting our trusted image resources, and act according to the event that's fired by Docker. And sometimes our applications are started repeatedly. When we are sleeping, some of the users can reach our website, but some of cannot. In that case, our application may be in a loop, and that loop caused continuously restarting application. So when our application is initializing, users cannot access. When it is killed or stopped, users cannot access. And afterwards, Docker can automatically restart our application, and the users can continue to reach our website. In that case, we should give up a way that an alarm should be created when our application is restarted, for example, more than 5 times. So we can just query Docker about the restart counts of a container, and we can just print a message, or we can just print list of the containers with their IDs or names, and their restart counts in the list as well. So what we want to filter is the containers that has been restarted for more than 5 times, or more than an arbitrary number of times that we want. So now we will implement actually these, sorry, let me show from here, this functionality. So in that case, we are just taking a list of containers from Docker, and in that containers, we are just getting the restart count attribute, which is in the Docker attributes list here. And if we just see that list of a container, we can see there is a field named restart count, and afterwards we can use that number to filter our containers according to a number we defined. The default number in that function is defined as 5, and we are just filtering them in that if structure and appending them to a Python list and returning that list. So by just using this function, you can just send the returned list to Telegram, to a monitoring system, or via SMS, or some other method you prefer. So it allows us to create some specific structures according to our needs. So actually, before going to CI/CD stuff, the last example I want to show is just filtering the containers running more than, for example, 7 days, because most of the environments we don't want to have containers that are running for months, because containers are mostly ephemeral, and we just want to see them being updated repeatedly and deleted, new ones are created. And for example, in some environments, their lifetime is limited by a couple of hours or so. So it's what we want, and just this structure here is iterating through the container list again, and just getting their starting time in their attribute list, attribute actually dictionary, and afterwards just parse the creation time using dateutils parser, and taking diff from the current time and the time that container is created. And if the difference is more than 7 days, we are just printing a message using that f string and including the container's ID in that message as well. So when you run that code here, you will just get a list of containers that are running more than 7 days in that case. So let me switch here again and show you the script running. Sorry, I just created a new virtual environment, so sorry, I don't remember its name. So let's deactivate this, activate my virtual environment, go back that one and Python, yes. And it will show long running containers if they are available, but for now, there are no containers that are running more than 7 days. So I will just switch that to minutes and run it again. Oh, sorry, I think I am not lucky here. So let's see to seconds to see whether, yes. So there are 2 containers that are running for more than 7 seconds, actually in that case. And we can just manipulate that scripts to fit according to our needs. So it's a way that it's a way to find out maybe there are some containers that are forgotten by the creators but running in our environments that may cause some security risks, that may run some versions of programs that are that have known vulnerabilities on them, or that are just being forgotten and consume system resources related to applications that are running on them. So it's an easy way to filter the containers, filter the applications that are running on our servers, and just getting the IDs for them to filter, or creating alarms, deleting them, or putting them in some pipelines. And the last example, actually, I will show is a CI/CD engine based on Docker and Python. This CI/CD engine is configured using a YAML, just like the example you are seeing right now. And using that YAML, you can just define your steps, giving a name, a Docker image, and optionally your parameters. And afterwards, it will automatically create a temporary directory and use that directory to store your files, and creating containers as steps. In that containers, your commands will be run, and afterwards, these containers will be removed and your pipeline will be finished. So it's basically what we are trying to provide with that CI/CD engine. And I will show you it is running demo, as well as I will introduce you its source code, because it is less than 200 lines and it's really easy to read and actually make some edits according to your needs, in my opinion, of course. So I have released that source code in GitHub. You can just access the source code. It's MIT licensed, so you can use it in your environments freely. And here is the Python code. But by default, let me talk about its default features. It's declarative, which means that you can just declare what you need instead of using an imperative language. It's YAML formatted, I just showed you. And your builds will be immutable, which means that one build will not affect the other one, even if they will be produced by the same code base or by the same repo. So different CI/CD builds will be isolated from each other using Docker technologies. And your builds or your pipeline steps will be actually built on Docker containers and will be triggered, managed, and removed using Python as well. So it's what we are trying to provide by default using Python Docker package. And it's available from now on. And I will show you a running demo by just using, this command. It's my dev environment, and I have started. It's integrated with GitHub, which is an open source Git web UI and Git repository. Actually, web UI is a better definition for that. And here is the GitHub's web UI running in my computer. So what I will do here is I have a repository here called random number. This repo is coded with Falcon framework in Python and just return a JSON which include a random number generated by Python between 0 and 100. It's basically what the repo is doing. So it's not doing a useful thing, but it's a good example for making demo. So the source code is quite short. It's my source code, and it's returning a random number and two different boundaries between which the number is in between. So our number will be between 0 and 100 in that case. So it's the repository. There is a Docker file. There is a Python file. Requirements txt file is residing here. And the only thing I should do is just creating a webhook which will trigger our CI/CD engine, and afterwards our CI/CD engine will start its pipeline and start executing the steps in that pipeline. So it's the usage. I am just writing the host name plus port here, and saving it will be enough for me. And here is my Python script. Let me open that script as well. It's our CI/CD pipeline engine. It's a minimal engine, but it provides all the actual features I just told. And if I just click test delivery, or if I just make a change here, for example, in README, let's edit it and edit, for example, edit comma here and commit my change, it will automatically trigger my pipeline here, and it started to execute the pipeline steps. And now it will be done, and my pipeline will be completed. So it created a, it's actually, what it has done is it has cloned my repository, and afterwards it installed requirements.txt, and it created a Docker image with this, and it pushed the Docker image to a Docker registry, which means that from cloning our repo to running some scripts in our code and creating a package and pushing the package to a registry will be done but by that engine. It's completely coded in Python, and what it is doing is it's just execute a pipeline on post request, and we are just getting the commit ID and repository's URL, and using that information we are cloning that repository and executing the pipeline we defined here. Currently it's just connecting and cloning a static repo, but the pipeline steps are executed dynamically according to this list. So we can just edit that list and create some other stuff. What Docker is coming into game in here is actually we are just providing the environment name as Docker image, and it will create a Docker container based on that image, run the command here in that image, and afterwards it will store the workspace in a constant, in a permanent place and remove the container. In the next step, it will create a new container, mount our workspace into it, and work on the changes and remove that container as well. So afterwards, the pipeline will be complete. And steps are just running container and executed by these lines. So these are the final lines I want to show you, because the core part in that pipeline engine is here. It's creating containers, running them, and completing its jobs. So these are I think the final things I want to say, and it's my information. If you want to reach me, don't hesitate to ask some questions, or I am actually welcoming any pull requests on the Git repo as well.
Thank you. I think you can post the link to your GitHub here in the chat, so I can just copy it to the Telegram channel. And yeah, just mention the delay with the YouTube and Zoom is just 30 seconds. So for a question in Telegram, we need to wait for a little bit, if there are any. And if there are any questions in the chat, so there are 10 people here, so you can just unmute yourself and ask the question, and video will also be very nice. So you guys, if you have any questions, oh, I see the link, thank you.
Welcome.
Yeah, so if anyone have any questions, you can either just ask it or just write it in chat, and Guray will just read it out loud and we'll answer it.
Yes, and if they will be in English, it will be easier for me to read.
I think we can translate it as well. So
okay.
I can
okay. I can also use the Google Translate, by the way.
Oh.
Okay. Okay,
Yes.
Thank you so much.
So wait a minute, I'll share the link. Yeah, so I don't think there are any questions, but anyway, if there is any, I'll just email you.
Okay.
So you will get the questions anyway. Henrik, what do you think? Do you want to start right away, or do you want a 10-minute pause?
As you wish, we can start now.
We mentioned in the agenda that you will start at 8, as I remember. So I do believe that we mostly have people here. I think we can wait for 5 more minutes and start a little bit earlier. Okay, is it okay for you?
Yeah, I don't mind.
Okay.
So, not to just sit and wait, I can ask a question to Guray. So, are there any major issues with your framework that you are trying to solve now, and what's your release plan for this?
So actually, the major part here is there is no CI/CD solution that is completely integrated with Docker Swarm in a way that we want to use. There are some solutions, but they don't provide the functionality we need, the complete functionality actually. So I want to start with a core, and afterwards add some features, like it's not currently, for example, provides secret management, or you cannot store your Git credentials in it for now, because there should be some solutions to store your credentials like a vault system in a secure manner. So it's the most common problem we are facing with it right now, and probably using Docker Swarm secrets and configs will solve it. but there will be some other challenge because in Kubernetes, in my opinion, it's really easier to achieve because in Kubernetes, you can just edit your secrets, you can manipulate them or remove and create them with the same name or different names. But in Docker Swarm, you should create a new secret and update your services with the name of the new secret, because otherwise your services cannot access the new secret without your intervention or without your actual update. So we are facing with that problems because they are all programmatic things, but they cause us some job, and we will work on it actually.
Yeah. But do you have any milestone plan for now?
Sorry, I couldn't hear.
Do you have any like the deadlines or milestone plans, like when you're going to finish and make?
Actually, it's a pretty young project, but our deadline for the first phase is at the end of the May, because we want to use it in the starting of the next month, and afterwards we'll be ready for implementing some more stuff that's requested by our users. But by the end of the month, what we want to access or provide is complete Docker Swarm integration, because there are a lot of companies that are using Docker Swarm in production, and almost all of these companies wants to use CI/CD or currently using CI/CD for a long time, and we want to provide them the chance of using this product directly, because we are open sourced it using MIT license, and it's the target of the first milestone actually. The deadline is at the end of this month, and the functionality will include Docker Swarm integration, and you can define your pipelines using YAML files from your repositories, or you can just create a config in Docker Swarm. Docker Swarm has a built-in config declaration opportunity, and you will store your configuration or pipeline in Docker Swarm, and Docker Swarm will just execute your pipeline steps by reading that config. So these are the implementation steps in the first milestone.
Yeah, I see. Thanks. I'll just start your repo on GitHub, so I'll follow to see what's coming.
Okay, thank you.
Can you please talk a little bit louder, because I believe it's a little bit undistinguishable?
Yeah, let's try.
Can you try to talk now? Because I believe it was muted.
Yeah. Do you hear me better now?
Yeah, now it's a little better.
Yeah, okay. So just switch the microphone.
Yes, okay. So I think it's time to start, and I want to thank Guray one more time, and I just shared the link to his repo to our Telegram channel, and if you had any questions, you can just ask it there, and we'll deliver it to Guray, and he will answer it. Thank you a lot.
Thank you so much. Have a good day.
Thank you. And our next speaker is Henrik. So you can just share your screen.
Yeah, let me do it. Yeah, so here we go.
Yep.
Yeah, so once again, hello everyone. Unfortunately, I can't see your happy faces behind your computers today because the situation is so. But I'm sure you're all doing well, and I hope everything passes very soon, and we'll be out of this wiser and smarter. And if you want to take your microservice architecture system to a very new level after all this, I'm here to explain how to do efficient logging today to uncover all the points you need to consider. But first of all, let me speak a little bit about myself. So I'm Henrik. I'm a software developer in data art, and I've been doing it actually for like 5 or 6 years now. Before I finally settled on Python, and I'm a huge fan of the Python, the language, and the open source project they are making. I've made a few contributions to the Python Software Foundations projects, including the C Python. I made some changes in the standard lib, and I advise you to do so because it's very interesting. Like you understand how it works, you get some knowledge, you see how well the project is organized. And recently, I've been working on some microservices with Flask and Falcon, and that's where I came across the problems, the issues of the logging in the microservices. All that said, let's move on. So, Sam Newman, one of the pioneers and the famous faces of the microservice architecture and all the fuss about it in the recent years, like tweeted once that if you want to implement microservices, the first thing you need to consider is to implement the aggregate logging, and the second is to implement the correlation IDs. And we'll speak about both today, actually. But before that, let's have some historical remark and remember how it was done in the good old days. Like there's the traditional approach of logging everything. And probably you all at some point came across this approach because unless you are young enough and you didn't live at the PHP/Java era of the web development. So at that time, everything was simple. There was a text file somewhere on your server where the application was writing your logs, everything that was going on there, and sometimes that file was divided into two for access log and the error log, and it actually came with a lot of issues. Like it was very hard to access. Every time you wanted to get something, you need to SSH to the server, you need to find that log, you need to read that log somehow, then you need to find what you're interested in from that log, and that's very, very complicated. Besides, the files were unencrypted, everything was open, it was a text file, there was always the risk that some sensitive data may like sneak in and live there, and some people may steal those logs for no good reasons. And also, one of the most famous issues were that those files were always getting bigger and bigger. Sometimes they were cutting the files into multiple ones, but eventually it was filling all your storage and you were out of your application was starting to not work properly. So eventually, recently, microservices came to the arena to solve most of the problems in the monolith systems, but they also came at a cost of making the logging issues even more difficult. There is usually a huge number of services. For instance, a couple of those, maybe a dozen, sometimes a few dozens, or even hundreds, like in case of big companies like Google and Facebook. And it's very, very hard to access to each of those to get access to the logs and to see what's going on there. Secondly, now the logs are spread all over the services, and it's extremely difficult to find whatever you're searching for. And also because the requests are sent back and forward between the services, sometimes you lose trace of requests. So seems like this is complete failure for the microservices, but there were some approaches people came up with that will help to avoid these problems. So once again, to recap, the issues are that logs are impossible to access. It's very, very hard to debug your application, and you lose the trace. So nowadays there are two main methods for distributed logging: log consolidation and log streaming. We'll speak about both today. So the idea behind the log consolidation is that the processing, the logging is done on the server. Then some application takes and sends those logs to the centralized server. For instance, using Logstash and bits, and then it is collected on the centralized one, processed and used as you wish. And the second approach is log streaming. Log streaming is when you don't log on your server, but rather you send all the logs to the centralized server where it's logged and where it's stored and processed. The benefit of log streaming is that you don't have the issue with filling the storage of your server anymore, because everything is stored on the separate servers and you don't need to do cleanups and everything. But the benefit of the log consolidation, on the other hand, is that it's more reliable. Like in case something is wrong with your centralized server, on log streaming you lose the data. But if you're using the log consolidation, the data will remain on the server, and the process of sending the log will continue afterwards when the network is back. So again, Sam Newman once in the same thread in the Twitter mentioned that it is completely insane to implement your own solution for the logging. And let him know if you want to do it. But because there are very good solutions available there. For instance, I worked with the Sentry, the Logstash, and currently with the New Relic, also Amazon's CloudWatch. They are all pretty good solutions, very easy to implement, and all have their benefits and disadvantages over each other. There are like more advanced solutions like Loginsight by VMware. But for today, let's speak about the ELK stack. I wanted actually to do it live, but I had some technical difficulties, and not to rely on VIT too much. I've made the example beforehand, and I'm going to show it to you now. So let's see the example of ELK stack. So ELK is Elasticsearch, Logstash, and Kibana. Elasticsearch is, you're probably familiar with it. It's a search engine. Initially, it was used to query and analyze the big data to find whatever you want from there. But along the time, it found many interesting applications like logging. For in our case, you can see what others are there. The second is Logstash. Logstash is log aggregation service. Basically, it gets streams logs from different sources. Then it transforms it to your necessary format, and then it stores it somewhere. And there are over 200 plugins for Logstash. It's pretty much so you can mix everything and create whatever you want. And the last thing here in this stack is the Kibana. Kibana is for visualizing your data. There are some other solutions, but Kibana is good because in real time it gets the changes from the Elasticsearch, and so you can see the real time log there. They're all pretty easy to install. For the Elasticsearch, the only thing you need to do is simply to specify the host location. The same for Kibana. You need to allow some hosts from accessing it, but the thing here is that it doesn't have the authorization, so you probably need to install the Nginx with the basic authentication for it. For the Logstash, it's the only place where you need to do some manual job. So you need to create these simple Logstash pipes that do see. Yeah, so in our case, it's very primitive, very simple. So we have the input. It gets the simple TCP requests in a certain port in a JSON format, and the output is RabbitDebug. It's a library used to aggregate and store. You don't have to know the details about it. And luckily for us, there is a good library in Python. It's called Python Logstash, which you can use to stream the log very quickly to Kibana and Elasticsearch. So one advice here is to have a common framework for logging, is because when you have different microservices, you need for each of those you need to maintain a separate logging. But in case you have a common framework or library, you can set it in just in one place, and everything will work with it. So, like very basic example of logging framework I have here. So as you see, I'm importing the logstash here, the library I've showed you, and I'm creating a test logging with this certain logger. It already has a particular default logging structure which it uses, and then it sends the errors, infos, and warnings. So like basically every time you want to log something in your application, you just can import this test logger and use it to send the data to the server.
Henry, I'm sorry. The next time you're showing the code, can you just make it a little bit bigger because it's slightly below?
Yeah. Let's do it. So
that's much better.
Yeah. Can I do more? So what I'm doing here is just importing the Python's default logging module. I'm using the logstash library I've presented you, and sys for something else. So I'm creating a new logger, like you usually do in Python's with Python's logging module, and we use this Python logstash logger for the preset logging schemas. Then by setting the level, the Python's logging module has this nice feature of setting what level of logging you want to have. You can have info, debug, errors. For instance, in the case of info, almost everything gets printed, but if you put it to, let's say, errors, only the errors get printed, critical errors. Then I'm adding the handler, which is this logstash TCP handler, which basically sends the log not to the standard output, but to the hosted server we have on a certain port. And then I'm using the error, info, and warning methods to print whatever I want there. There are some extra possibilities. For instance, you can have a dictionary with all these Python default types and use those to provide some extra data on the request. And one of the benefits of having common library is that it's relatively easy to switch between the different methods for logging. For instance, we have the log consolidation and log streaming. For instance, you've implemented the log consolidation, and now everything is saved, and then it's sent to logstash and centralized server. But now you're running out of space, and you just want to implement Kafka, let's say. But in case you have like 200 servers, you need to do it every place. But with a unified library, you just can change it in one place and then move on with all the services. And the other thing is the correlation ID that keeps the trace of the request. It's very simple. Basically, every time something gets to your API gateway, you create a unique ID for that trace, and whenever it is sent across the services, the same correlation ID is saved everywhere, and then you can see from which service where the request went and where it failed, and you have all the trace, and you understand. It's better for recreating the failures. And finally, about Kibana. I've used this test data. So we have these logs here. Still, it's very hard to understand what's going on here yet. But it's better than having log files somewhere in your command line, because you have this very interesting search functionality here. Also, you have this histogram here where it shows at what time how many requests are made. And the real benefit comes from this monitoring. So we have this dashboard here. It actually takes some time to load, so I've already opened and preloaded it. So we can have any kind of statistics here. Like, for instance, in this case, I have the percentage of each of the operating system that was in use. I can find it by country. I can see how many unique visitors we have by the IP address we have in the log. Also, the how many bytes are there. So many interesting statistics. What types of files are requested. Some interesting, not quite understandable graphs about which countries are used, and also these interesting maps that you can implement. For instance, this one is for US, but you can implement for your own country or for the world, and to see, for instance, which states are more frequently requesting and using anything. So basically, the few lines of code we have here is this one. Probably only this part is then converted into a really beautiful monitoring and logging platform like this. Yeah, and that's probably it. I did it very quick. And I'll post the source code on GitHub, so if you want, you can have a look and try doing it yourself. Actually, I very much advise you to play around with the 200 plugins of the Logstash, because there are a lot of interesting things there, and also try to come up with your own statistics and estimates. Try to find some interesting insights in the data.
Can you please share the link to your GitHub as well?
Yes, I will send it to this chat in a bit.
Yeah, you can send it to the chat.
Yeah, sure.
It was pretty quick.
Yeah, I thought it would be longer, but.
So there is no questions right away, but again, for the people who are here in the chat or in YouTube translation, you can unmute yourself and ask your question, or write it in the chat, or just write it in the Telegram chat via the link under the video. And if the translation ends till the time, we'll just send the questions to Henry. He will answer it, and we'll just get back to you with the answers.
Yeah, sure.
It's quite interesting then, just like 3 lines of code converted into the beautiful monitoring system.
Yes, very interesting and easy. Like the other beautiful thing here is that almost none of these tools were initially created for logging. Like Elasticsearch were just created for searching and querying some data. But like you see how, like, combining different existing interesting solutions, you get something bigger and something like more fascinating.
You are also using the library, right? The Python hash.
Yes, Python Logstash.
Yeah, can you just also share the link? I'll also share it.
Yeah, sure. I'll send all the resources.
Thanks.
Yeah. Also, I can probably also post some resource how to install and implement the ELK state. It's very straightforward, but anyways, for different operating systems, it's different, and I can like share the resource. So if you want to try out, you can. Yeah,
it will be really great. I do believe that you can send it to us with the presentation, along with the presentation, so we can post it under the video. So the people can just follow the links under the video and go explore themselves and just start doing it.
Yeah, I'll email you right after this. And if everyone wants to experiment anything, you can like contact me and we'll see.
Yeah, we'll share also the contacts of Henry and Guray, so you can just contact them yourselves and ask the questions directly. Okay, I do believe that that's it, and there is no questions today, but we'll let you know if there is. Okay.
Yeah. Okay. Thanks.
Okay. Thank you to both of the speakers, and thanks everyone who joined. We'll see you in the next Python meetups. Just stay tuned. Follow our Telegram or our email digest, and we will let you know about the new Python meetups or events, and of course the conference. this Saturday. The people in chat just said thank you for both the speakers.
Thanks.
Thank you. Yeah, thank you guys, and see you. Yeah. Bye.
Thanks. Bye bye. Have a nice day.
Yeah,
Thank
you
you.
too.
Bye.